I'm left with 2x. Come on. 2x. And then negative 6x dividing that by 2x. Negative 6 divided by 2 is negative 3. And the x factor is out front. And then I'll look at these two. What do they have that I can factor out of both of them? They are both divisible by 5. That's the largest one. They both do not have an x, so I cannot factor an x from it. But when I do, factor a 5 from the 10x, that's 2x. Factor a 5 out of the negative 15, that's negative 3. And that's really what I was hoping to see happen. When I do factor by grouping, I should get whatever's in this parenthesis set to be the same thing. If I've done it right, it'll be the same thing because that, now if they're not the same thing, either I did something wrong over here, or I factored when I divided something wrong, or it's not factorable. But in this case, they both have the 2x minus 3, so that means I have this giant term, and I have this giant term, and I'm going to be dividing the 2x minus 3 out of them both. 2x minus 3. So that gets essentially like undistributive property. It comes out in front of both. And leaving me then with this 2x plus 5. And that would be factor by grouping. To know that you did it right, the way you would check it would be to do FOIL. If you run that through FOIL, first, outside, inside, last, and you simplify it, it should, if you did things the right way, give you this thing up here that we started with. All right. So if it foils out to that initial part up there, then we did the same thing. So again, this was just to get us going and thinking because we covered this last week. Factor by grouping and the process. The biggest thing you need to remember is the process. Will there be a question about factor by grouping on the exam? Absolutely there will be.
How did you get the 2x plus 5 at the end? Okay.
Oh, when this 2x minus 3 gets factored out in front, I'm left with 2x. When this 2x minus 3 gets factored out in front, I'm left with the plus 5. So that's the 2x plus 5. So similar to how I did this here. From this one, I factored a 5 out of here. So I factored a 5 out in front. And that left me with 2x. I factored a 5 out of the 15, leaving me with a negative 3. It's doing the same idea, but it's doing it with a bigger chunk of something. It's not just a number. It's actually an entire parenthesis set. And if I want to think about it, you could think about it like this. I really did 2x minus 3, and I divided both of them by 2x minus 3. And when I do that, these two reduce, leaving me 2x. These two reduce to 1, leaving me with plus 5. All right. Apologize on that special form. There we go. Which is there a way that I can factor either of them into something else that I know? So 2y cubed is just a monomial. Monomial, one term. All right. There's no adding, subtracting. This is a binomial. If it were a quadratic, like where we started from, maybe we did factor by grouping. This isn't all the way that way, but this is a special form. It's called a difference of squares, which I know I've said before in this class. I'll say it again. And if you take me for intermediate algebra, you'll hear me say a lot more times there. Difference of squares is one of those special types of forms where it's of the form a squared minus b squared. Just one number minus another number, but both of them are squares. And it factors as y and y 1 and 1, because y times y is y squared. 1 times 1 is 1. And then it's plus and minus. The reason why it's plus and minus is when I do FOIL, the middle number will be a plus y, and the other middle number will be a negative y, and the plus y and negative y add to 0. And I know that because there is no middle term. It goes y squared down to 1. It's not y squared plus something y plus 1 or minus 1. It's just y squared minus 1. So it's a difference of squares. And then out in front, I have 2y cubed. We'll do some more. Don't worry if you're looking at that going, I just don't remember this. But difference of squares is something you should really make note of. Again, in preparation for the final exam, yes, there will be at least one that has a difference of squares. All right, so now it's fully factored. And then the answer is, well, what are we going to do with this? What you have to look at when we're thinking about this is I have this thing here, that first thing, which is the 2y cubed. All right, then I've got this other thing, which is like a y plus 1. And then I've got this other thing, which is a y minus 1. Ooh. There you go. So you got these three things that are all multiplying. The reason why we do factoring is it's going to help me then solve equations like this. But before we do that, we're going to just kind of think about this for a second. So if you have x minus 5 equals 0, the answer to this question is, well, what is x? What number do you put into x that makes this whole thing equal to 0? The answer is pretty easy. You go, well, 5. Because 5 minus 5, that's 0. So what if I have this as my expression? 3 times something is 0. Anytime I have two things that are multiplying, I have 3, and then I have the parenthesis x minus 5. I've got two things, and they're multiplying to 0. In order to multiply 0, one of them has to be 0. And I know 3 is not 0, because 3 is the number of 3. So they look at this and say, well, how can I make this 0? What number would I put in for x that makes this 0? 5, which is what we just did up here. So it'd be 5 minus 5. So the solution, so if this was an equation, and I said solve this, we'd be like, oh, I know that x equals 5 is a solution to that, because if I put 5 in there, 5 minus 5 is 0. 3 times 0, 0. And then I have this now, where instead of x, or sorry, instead of 3, I've got this. So then I look and say, well, what number can I plug in right here for x so that I go this times this is 0. Well, actually, I know this one already because we've done that one now 3 times in a row. So into the equation, if I put 5 minus 5, well, that's 0. 0 times 5, because again, if I put 5 in, I got to put it in for both of them. 5 times 0 is 0. All right. Is there a number that I could put in here that when I multiply it by whatever's in the parentheses would also equal 0? The answer is yes, because if I put in x equals 0, 0 times, well, this is 0 minus 5. 0 minus 5 is negative 5. 0 times negative 5 is 0. So in this scenario, there would be 2 answers for what makes that 0. So then if we go back to this equation, now we're going to actually solve it for 0. When you have a polynomial like this, what you want to do when we're solving a polynomial is first thing is first, move everything to one side, have it set up equal to 0 on the other side. Then we do it like we did before. Find the GCF. 2y cubed. Leaves me with, that's not a 2, leaves me with y squared minus 1 equals 0. And then I factor it again. So I'll have 2y cubed out in front. And then this I said, oh, yep, that's a difference of squares. We just did this one. Y plus 1, y minus 1 equals to 0. Then there's a couple ways you can do it. At the beginning part, we're going to take it slow and use like every single step possible. But what I want to do is look at each of the 3 items. This thing times this thing times this thing. So the first thing I'm going to do is I'm going to say 2y cubed. I'm going to make that equal to 0. Because if that's 0, 0 times anything is 0. And then I look and say, well, what makes this 0? we can really go rudimentary and say, well, I divide by 2. Y cubed equals 0. Because 0 divided by 2 is 0. What number times itself 3 times is 0?
0.
0. So for this one, we get y equals 0. Then I'm going to take this one, and I'm going to set that equal to 0. Y plus 1 equals 0. Solve for y. Subtract 1, subtract 1. Y equals negative 1. And then I take this one, set it equal to 0. Y minus 1 equals 0. Add 1 to both sides, y equals 1. And then, when in like all things, how do I know I did it right? Take this value, this 1, going to go back up to the original equation. 1 to the 5th power. 1 times 1 times 1 times 1 times 1 is still 1. 1 times itself is always 1. 1 times 1 times itself. 1 times 2 is 2. So this first term is 2. Then I have this here. 1 times 1 times 1 also is still going to be 1. Times negative 2 is negative 2. So I'd have 2 minus 2, and that is 0. If I put 0 in, 2 times 0, 0. 2 times 0, 0. 0 minus 0 is 0. And if you did the negative 1 in here, you get the same thing. Negative 1 cubed. So it's negative 1 times negative 1 times negative 1. 3 negatives, that would be negative 1. Negative 1 times negative 2 is positive 2. So this is positive 2. Here, negative 1 times negative 1 times negative 1 times negative 1 times negative 1. There's 5 of them. It would be negative 1. Negative 1 times 2 is negative 2. So negative 2, positive 2, add to 0. So here's what we're going to do. We're going to do several of these all in a row. We're going to factor them. We're going to graph them. And we're going to find what are called the zeros. So first thing first, I want to factor. So I'm looking at this equation. And I'm looking at this last term. Actually, first I look and I notice there's no greatest common factor. They all do not have x's, nor do they all have numbers that are divisible by something else. Since this first number is 1, I do not have to do factor by grouping. I can just go straight to factoring. So I look at the last term. The last term is negative. That means the two numbers, one of them is going to be positive. One of them will be negative. X will be the first term in each of the parenthesis sets. And then, since this is negative, which means one is positive and one is negative, the middle number tells me that of the two numbers I pick, the bigger one will be the negative number because that has to add to negative 3. So I'm thinking, what two numbers multiply to negative 4 that add to negative 3? We've done this a lot of times. If we do negative 4 times positive 1, negative 4 times positive 1, that's negative 4. Negative 4 plus positive 1 is negative 3. Those are my two numbers. So this is 4. Oop, that's not 3. This is 1. That's what those two numbers give me. The negative 4 and the positive 1. And this equals y. Y equals that. To graph this, a couple ways about going about it. The easiest thing to do first is if I find a number here like 4, and you'll see where I'm going with this in a second. If I put 4 into this part of the equation, 4 minus 4 is 0. This parenthesis is now 0. 4 plus 1 is 5. 0 times 5 is 0. So I'm going to go and I'm going to choose x equals 4. Let me do it like this. We'll make a little table. X, Y. If I pick 4, y is 0. If I pick negative 1, and you might think, how is he getting these numbers? I'm looking at this thing and saying, what makes this 0? Negative 1 plus 1 is 0. 0 times anything is 0. So this is also 0. So if I go to my graph, 1, 2, 3, 4, 4 comma 0 There's that dot. -1, -1, 0, 0, there's that dot. Factoring helps me graph it in many ways. So again, first step was, if you're tracking steps, GCF, greatest common factor, get it out in front. They didn't have one. Second step, my leading coefficient is 1, so I'm going to factor this. Step 3, find the numbers that go in here and here that make it 0. Those are the 2 points I pick. The next step, and this is the one that just gets a little bit, throws some people off and they go, well, what do I do next? Is I look at these 2 points and I want to go halfway between them. So to go halfway between them, I first am going to look and just see, well, how far is it between them? So I'm at -1 at that point. So if I go 1, 2, 3, 4, 5. It takes me 5 to get over there. Again, if I'm at -1, I'm going to +4. You can also think, well, what's the difference? 4 minus -1 is 5. Either way, it's 5 units from here to here. I want to go halfway between them, which is 2.5. Half of 5 is 2.5. 1, 2.5. Which puts me at the point right there, which is 1.5. That's the halfway mark. Again, how I did it, I counted from the bottom to the top or top to the bottom. Either I went to 4 and I went 1, 2, 3, 4, 5 units to the left, half of which is 2.5. So go back up 2.5 units, 1, 2.5 units. Now it doesn't look like that's halfway, I apologize. But that's the halfway mark, and that's at 1.5. The third thing I'm going to do is I'm going to take 1.5, and I'm going to take that 1.5 and I'm going to put it in here for x. What I want you to do right now is grab your calculator, do order of operations, plug that in there, and find the correct y value, and then we will do the next step. So you plug that in, and you should get, what did we just say, negative 6.25. So what that does for me on my graph, which I'll extend down a little bit lower, 1, 2, 3, 4, 5, 6.25 is right about there. So that point right there, that dot that I'm trying to make, is 1.5 over and negative 6.25 down. That's that coordinate. I have a parabola. That's what a quadratic is. It's a curve that looks like that. To graph them, realistically, 3 points is all you need. Once I factor, factoring is going to give me these values on my axis, on my x-axis, right? The number here that makes it 0, that was 4. The number here that makes it 0, that was -1. And then halfway in between them, and I put that number back into my original equation, and it's down here. I'm going to sort of connect them with this like U-shaped graph, and that's a parabola, that's a quadratic function. So now we're going to do the same idea again, but first thing first, we need to get it into a form that we're supposed to have. So the way we have to do this in order to solve it, that's what we're doing, we're solving this equation, is we're going to move it all the x's to one side, all the y's to the other side. Well, there is only one y, which is nice. So we're going to subtract 4x from both sides. And I'll have, and if it's okay with you, I'm just going to write my y on the left side. It just feel better that way. On the right side, I'll have x squared minus 4x plus 4. The plus 4 cannot be added to that negative 4x. So it doesn't matter that I wrote it underneath it. And then we do the process. Is there a greatest common factor? Nope, there is not a greatest common factor. Can I factor it like this? X, X. I'm looking for two numbers that multiply to 4, positive 4. So they multiply to positive 4, which means they're either both positive or both negative. And since the middle number is negative, that means they're both negative. So either -1 times -4 or -2 times -2. And I look at those and say, well, does either of those pair add to the middle number, -4? Yes. This one. So it's x minus 2, x minus 2. All right. And then I'm going to go to try to make a graph out of this thing. Didn't mean to angle it quite so much like that. There we go. When is this 0? When x is positive 2, 2 minus 2 is 0. So I put 2 here. The y value is 0. So I go to my graph at 2, 1, 2, and at that point, it's 0. So there's a dot right there. What makes this 0? 2 minus 2, well, it's the same thing. 2 minus 2, it's also 0. So here's a case where if I only do 1 point, I don't have much of a graph left. Because I only have 1 point. What do I do with it? If you get to a case like this, your next best point to use for x is 0. Back in the day, I would always talk to my students to say, pick convenient points. Pick convenient numbers. What makes it convenient, you say? If I put 0 in for x, 0 minus 4 times 0, well, 4 times 0 is 0. 0 minus 0 is 0, plus 4, it's 4, which means my 1, 2, 3, 4. When x is 0, y is 4. That point is right there. Parabolas are what are called symmetric. That's why when we did the last problem on the last slide, we found those two numbers on the x-axis, went halfway between them. That halfway between them is the line of symmetry. And we went down to where the vertex was. And the vertex was the bottom of the parabola. In this case, whenever you get something like this where it's the exact same number, that means my vertex is on the x-axis. So that's the bottom of my parabola, which means this point is going to be reflected directly over here the same exact way, because my line of symmetry goes up and down. Way back in the day, when you first learned about line of symmetry, maybe you talked about like as a mirror, or if I like folded my paper over on top of itself on the line of symmetry, where would the other point go? This other point will go over here, right there. And it's 2 more units over, right? Because this is 2 units over. So then 2 more over and the same amount up. And this is 1, 2, 3, 4. So if I were doing my table, and if I put 4 into my equation, it should spit out the number 4. If I've done my line of symmetry the right way, and I can just quick check it. 16 minus 16 is 0, plus 4 is 4. Yay. There it is. So there's my 3 points. I can now sketch my parabola. I missed it there a little bit. This point should be at the bottom of the parabola, but that point there is called the vertex. Here we go again. It's already set up so that the y is on one side, my variables and numbers are on the other side. I look and see, is there a greatest common factor? There is not. Is my first coefficient a 1? Yes, it is, but what's missing? I do not have just an x. It's usually like this then, which I presented it that way back when we introduced this the first time. Okay, that's just a really bad looking 5. I'll just make that a better 25. There we go. If there isn't a middle term, that means it's because the middle term was 0. And you just don't write 0. But that's what it is. Or you could look at this and say, wait, this is one of those special forms that he has said so many times already factors into a very special way. two numbers that multiply to negative 25 that add to 0. Or if I look at this, I go, oh, it's the difference of squares. These are both things that have been squared. If you square x, you get x squared. If you square 5, you get 25. And it factors into one of them is plus, one of them is minus. And that's my equation, y equals. To graph it. The nice, convenient, easy numbers are, I look at this and say, what makes this 0? If I choose negative 5 plus 5 is 0. 0 times whatever this parenthesis set is, 0 times anything is 0. Look at my other parenthesis set, x minus 5. What number would I put in for x to make this 0? What number minus 5 is 0? 5. So if I put x in as 5, I'll get 5 minus 5. That's 0. 0 times, well, 5 plus 5 is 10, but 10 times 0, 0. Those are my 2 points where I cross the x-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is negative 5. This is positive 5. So I cross the x-axis here. I cross the x-axis here. And then the procedure is go halfway between them. Halfway between them is 0. So if I go into my equation up here and I put 0 in for x, 0 squared, 0 times 0, 0. 0 minus 25.
0.
0 minus 25 is then negative 25. So again, put the 0 in for x. 0 times 0 is 0. 0 minus 25 is negative 25, which means this point, now my graph is going to be really off. I'm going to have them incremented differently. So this on the y-axis is negative 5, negative 10, negative 15, negative 20, negative 25. Can you do that? Can you scale it differently? You can. It's better if you don't, but I just didn't have space here. I have my 3 points. Oh, I missed that one. We're off the edge of my screen there. So there's the parabola that goes through the 2 points. And the zeros, in this case, when it says find the zeros, x equals 5, x equals negative 5 are the zeros. They're called the zeros because if I put them into the equation that we started with, it gives me an output of 0. That's why they're called zeros. Here now, we're not going to graph. We're just going to factor and find zeros. The reason why I know I can't graph this equation is there's no y value. Now it's just x's. Procedure, though, stays the same. Move all the numbers over, or all the things over, so that I have the entire equation equal to 0. Next step, do I have a greatest common factor? I do not have a greatest common factor. 3, 4, 15 do not have common factors. All of them do not have an x. My first coefficient is not 1. It's now negative 3, which means we are back to where we started today with factor by grouping. I need to take a times c. A times c will be negative 3 times 15, which is negative 45. And now I'm thinking, what numbers multiply to negative 45? Just in general, you can start with 1 and negative 45 multiply to, but that's not going to help me much because I want them to add to 4. That's, negative 44. We have 5 times 9. One of them has to be positive, the other one has to be negative. Which one's which? The 5 will be negative. How do I know? Because the middle number is positive. So if I have two numbers, the bigger one has to be positive if it's going to work. Do these numbers multiply to negative 45? Yes. Do these two numbers add to positive 4? Also, yes. That's the set I'm going to use. So now I'm going to split this up. Negative 3x squared minus 5x plus 9x plus 15 equals 0. Again, does it matter if I have this as the 9x and this as the negative 5x or vice versa? It doesn't matter the order. Because no matter what, those two will add to positive 4. So now, do these have factor by grouping? Looking for greatest common factors. 3x squared and 5x, or I should say negative 3x squared and negative 5x. Do they have a common factor? Yes, they do. They can both be divided by x. But because I like it to be positive, I'm actually going to factor out a negative x, leaving me with 3x and positive 5. So again, look, I divided that negative out of each. Negative out of the negative 3, so it remains a positive 3. One of the x's out of the x squared, so it's now just x. Out of the negative 5, I factored the negative, so it's now positive 5. And from it, I also removed the x out in front. Now I look at the next two. Are they both divisible by something? Yes. They're both divisible by 3. 3x plus 5. And again, if I've done this the right way, I will have the same thing inside the parentheses after I factor in the groups. And that 3x plus 5 factors out. And what's left? On the left side of that, the 3x plus 5 gets factored out. I'm left with negative x. On the right, the 3x plus 5 comes out, and I'm left with plus 3. This equals 0. And then the last thing it says to do is find the zeros. And here's where, if you've done this enough times, you're going to start to see it. But if not, I'm going to take each of these and write them as individual equations. Negative x plus 3 equals 0. Subtract 3 from both sides. Negative x equals negative 3. I got to get rid of the negative sign so I can just get x by itself. So if I divide both sides by negative 1, I'll get x equals 3. Which if we go back and just look at it, if I put 3 in here for x, that's negative x, so now it's negative 3. Negative 3 plus 3 is 0. Take this one over here. 3x plus 5 equals 0. Subtract 5 from both sides. 3x equals negative 5. Divide both sides by 3. X equals negative 5 thirds. That might be a harder one to just look at and say, oh, I know the answer to this. That's negative 5 thirds. Because negative 5 thirds times 3 is 5, negative 5. There. But these will be then the two zeros, x equals 3 and x equals negative 5 thirds, which if you would go back to the original equation and plug them in, if you put 3 in for x, 3 in for x there, and solve that through, you would find out that the entire thing equals 0. Where is this all headed to? It's headed to problems like this. So we've done all like the nitty gritty, little nuts and bolts. We did several examples, but then this becomes an equation with actual some background to it. In physics, projectile motion, things like that. H of t, the height, is a function of t, is negative 16t squared plus 48t plus 160. So that's the height of that's the height function of a ball that's thrown vertically, so straight up in the air, with an initial velocity of 48 feet per second, and that's what that 48 stands for in the equation. From the top of a building that's 160 feet tall, that's this. All right. So if I were to graph this function, I'm only going to care about this portion of the graph because time, t, is on the x-axis. And the shortest amount of time something can happen is at 0 seconds. And at 0 seconds, that ball is up here, 160 feet. Or if I look at the equation, put in 0, 0, 0, 0 plus 0, 0, plus 160 is 160. But I want to find out when I launch this ball, throw it up in the air, if it goes up in the air and then comes back down, assuming it just misses the edge of the building and comes down, how long does it take to hit the ground? In this scenario, the ground is the height. So what is the height of a ball if it hits the ground? The height would be 0. So here's what we're going to do, and then you'll hopefully see as I work through it where we're coming up with these values. But I want to find out when is the height 0. 48t plus 160. Finding out when the height is 0. And the reason why 0, because 0, I'm going to get rid of that one right there just so it's not in the way. 0, like we did in the other equations, finding the zeros. In this case, 0 is my ground level, so I want to find out when it's going to hit the ground. So the first thing I do is I set my equation equal to 0. Next thing I'm going to do is look for a greatest common factor. Do they have a greatest common factor? Here's where it would be helpful if you had a calculator, unless you know your times tables pretty easily. Is 16, 48, and 160 all divisible by 16? And I'm going to divide a negative out because, again, when we're doing this, we like it to have the positive leading coefficient. First term is a positive 1. So I'm going to factor the negative 16 out. 16 out of the 48. Negative 3t. And then negative 16 out of 160, negative 10. You got to be real careful with those negatives. Now that we're factoring a negative out, it changes the sign on every single one of those. And now, negative 16, this equals 0 over here. This equals 0 over there. Two numbers that multiply to negative 10 that add to add to negative 3. Add to negative 3. So 5 and 2 multiply to 10. 5 and 2, the difference between them is 3. Which one's positive, which one's negative? Since the middle number is negative, that determines the bigger number is negative. This is negative, this is positive. And again, if you FOIL that out, you would find out that, oh, yep, that actually does work. What makes this 0? T equals 5. What makes this 0? T equals negative 2, which you might think, is that possible with time? So if I go over here to negative 2, that's a 0. I go to the right to positive 5. 1, 2, 3, 4, 5. To positive 5. That's a 0. But this point up here is not my vertex. The vertex would happen halfway between them. That would be at 3.5. How do I know it's 3.5? 5, between 5 and negative 2, that's 7. Half of 7 is 3.5. So 1, 2, 3.5 would be right there. And my vertex will be up there somewhere. But anyways, what happens is, if we could go back in time, this is where the ball would have maybe started with had it been an actual projectile. But instead, it started at the top of this roof and went up and down. So this is positive time. This is in the land of the actual living. This is like before time. But a scenario like this, where you're doing projectile motion. Now this is just throwing it vertically up. Just straight up and then straight back down. If you get to pre-calculus, then we'll actually add into it, how do we know, like if we're doing it at a certain angle, how can we get there? But for what we're doing, this is another example. We're finding the zeros because we're finding when it hits the ground, and we said, well, ground is when it hits, the height is 0. And then the process of setting it up, greatest common factor. In this case, we did not have to do factor by grouping, because after I factored out the 16, my first term was 1. So then I could just do just these 3 things and do factor by, the direct process of reverse FOIL. So when we look at this and we don't have, there are no 2 numbers. So again, we're looking at -3 times 1, that's -3. But to add those 2 numbers gives me a -2, and I need it to be -1, because that's a -1. So I try 3 times -1, also -3. But if I add those 2 numbers, it gives me +2, but I want it to be a -1. So when I can't factor it, I'm going to use, to find the zeros, a function called the quadratic formula. This, what appears to be ugly formula, is actually quite elegant in its proof and derivation for where it comes from. But this will work every single time. So if you're like, I just can't get the factoring, but you can memorize a formula, memorize the formula, it will work every time. And it will give me the roots. X equals -b plus or minus square root of b squared minus 4 times a times c. And that's all under the square root there, that one is. And on the right-hand side is everything is over or divided by 2 times a. Now, a, b's, and c's go back to my original equation. Ax squared plus bx plus c. So to do it as an example of this problem, my a for my equation up there is 1. It's the number in front of the x squared. That's a 1. My b is the number in front of the x, which is, for my case, -1. And my c is the number at the end, which is -3. So to do this, I'm going to move that up a bit. We'll hide that part too. I would do x equals, so I take the b value. See the b value? The b is -1. I'm going to take -b. Well, if it's already a negative, it's a negative, which makes it a +1. Plus or minus the square root of b squared, -1 times -1, +1, minus 4, and here I'm just going to put the other numbers in for a second, times 1 times -3, all over 2 times a. A is 1, so 2 times 1 is 2. And now I'm going to follow and do my order of operations. 1 plus or minus the square root of 1. -4 times 1 is -4. -4 times -3, +12. So this would be 1 plus 12, all over 2. 1 plus or minus the square root of 13, because 1 plus 12 is 13, all over 2. And then I go, I don't know the square root of 13. But if I take my handy-dandy calculator and do 13 square root, that number is 3.0 do this. Move that over there a little bit more. So this would equal 1 plus or minus 3.6055. It's actually 555. So we'll call that last number there a 6. 606. It actually goes on a lot longer than that, all divided by 2. Which means I'll have two values. First I'll go 1 plus this number, so plus 1, and then divided by 2. And that number is x equals 2.303. I'm just going to round, that's a 3. And then if I take that and go 1 minus 3.606, because that was the numerator, divide that by 2, my other answer is x equals negative 0.803. So these are the two zeros, that is, of that original equation that I had up there, that's where it crosses the x-axis. All right. Just because I can't factor it doesn't mean there aren't zeros, it just means they're not fun ones. Six, 5, and 6, 6. Putting in this time. If you have not yet done the the exam 2 review problems, you're going to want to get that done sometime. If you've done it, you can definitely go back and do it again and again and again until you get all the points possible. But that's the other thing you should be doing right now. And then I'll be having at the beginning of each of these last 6 classes, like we did today, example problems related to some stuff that was relatively newer, some stuff that goes way back, but all of this is prep for the final exam.